We've had a similar goal for quite some time. It was compute the derivative of as many functions as possible, and we have done a lot. We figured out polynomials and trigonometric terms. We figured out how to do things like the product. We figured out how to do things like a composition. We know how to do quotients. We know how to do sums. We know an enormous amount. But there's one class that we don't know yet, and that's exponentials. For example, we do not know how to take the derivative yet of x to the power of sine of x. So how can we solve something like this? What I want to exploit is a nice little fact about logarithms. And the fact is this. If I'm going to take the natural log of a to the power of b, then one of the rules of logarithms is that this exponent that I have, it can come brought down at the front, b times the natural log of a. Now, I want to suppose you're taking the derivative of this. If exponents are hard, things like x to the sine x, if those are hard, well, we do know what the derivative of a product is. We've got the product rule for that. So because the natural log sort of transforms exponents into products, it's going to be able to transform something that's challenging into something that is effectively just a product rule. So let's see how this actually works in an example. I can take my y equal to x to the power of sine of x. And before I just try to compute dy dx, I'm going to go and take the natural log of both sides first. That is, I'm going to compute the natural log of y and the natural log of the x to the power of sine of x. And then our goal is going to be, if I have it written in this form, I'm going to take the derivative of both sides here. Now, why have I helped myself? The key idea is this. I've got the x to the sine of x. This is kind of like an a to the b. And I can apply my log rule. I can take this sine of x and I can bring it down. So what this is going to have on the right-hand side is the derivative of the sine of x times the natural log of x. What happened over here on the left? Well, this is a chain rule. An outside function, the natural logarithm, the inside function, y of x. So what's its derivative? It's the derivative of the outside, which is 1 over whatever the inside is, 1 over y, times the derivative of the inside, dy dx. That's me applying my chain rule. So I apply my chain rule over here. I've applied a log rule over there. I can take the derivative of a product, and I take the derivative of sine times the natural logarithm of x. I just use the product rule. So what do I have? I'm going to leave the left-hand side. Sine goes to cos plus the natural log plus sine times the derivative of the natural log, which is 1 over x. So I've applied my product rule here. Okay, so I'm happy with this, but I want to do a little bit more work. Let's get rid of all this other nonsense. What I want to do is, I don't want this y here any longer. I want my derivative just to be some function of x. So I want to manipulate this, but I can both move the y up to the other side, and I know that y is x to the power of sine of x. So I can isolate it and take this y here, move it over, and what I get is the derivative with respect to x is, there's the y, x to the sine of x, times all of this other stuff. So that is my final answer for the derivative with respect to x of this function x to the sine of x. And you can see that it is kind of a long and messy expression here, but this is just how this logarithmic differentiation works. It makes it possible for us to compute a derivative that we didn't know how to do before.